Can everyone see my screen? You should see a slide that's called Intro to Programming, or What is Programming? Someone give me a thumbs up. That's what you see. Okay, perfect, thanks. Okay, great. So, yep, cool. So this slide just looks somewhat familiar, and it's because today we're moving into JavaScript, which is probably more on what folks typically consider as more of the traditional software programming. Not to say that HTML and CSS are not, but they're fairly basic in terms of the complexity that exists there. Whereas when we think of higher level languages like JavaScript, here's where you can do some really crazy, cool computational things and essentially build up all the functionalities that you see on traditional websites or web apps. So before we go to JavaScript specifically, once again, just to kind of recap something we talked about on Monday. What is programming? It's transforming input into output. And so we did a little bit of this in CSS and HTML, but now we're going to do a lot more of it here in JavaScript. The logical and the decision making becomes even more apparent because once again, as with any computer functions that we write, we need to be very, very clear about the directions. Computers cannot just figure it out on their own. We need to kind of give them as explicit as possible instructions on what to do at all junctures. Repetition is social and is creative. Okay, so these are all the things that make up kind of what we consider to be core programming at Full Stack. And the three parts that are actually all very important in terms of the development process are coding, testing, and debugging. A lot of people get hung up on coding, as in writing new code. They think that that's kind of the bulk of their value add or what they work on as a software developer. But you ask any experienced developer, and I would probably say testing is going to be probably 25 to 30% of what they do. Debugging is going to be another 30 to 40% of what they do. And writing fresh new code will probably only be 20 to 25% of what they do. And the reason why for that is because writing the code itself is easy. Testing it, making sure it works correctly, and then fixing any issues that don't work, that's the part that takes a heck of a long time than just writing new code, right? It's the same thing that if I was to write a book, right? Writing the raw text for the book is actually pretty easy, right? It's a proofreading. It's getting my thought process in order. It's making sure I'm saying the right messages. Like those things take a lot longer, and it's no different in programming. So just so you guys know, one of the things I'll harp on quite a bit throughout the rest of this class is, especially with regards to things like JavaScript, where you're solving problems, always make sure that one, you understand what problem you're solving, and then two, you understand how you're thinking about your solution before you start writing code. Right? So very often I see people who are first starting off thinking, oh God, I see a problem here. Let me just start writing code and see what happens, right? I might have used this analogy with you already before, but it's very similar to someone saying, hey, let's build a house. But rather than building a blueprint of how to build a house, let's just start like nailing planks in random places and hope that by the time we're done that this is a house that someone can live in. Which is to say that it very, very rarely works. Right, the biggest reason why people get stuck when they first start writing programming is, or when they first start programming, is that they haven't thought through what they actually want to write. They start writing code, and then their code actually confuses them even more. So clarity of thought is by far the most important skill that you're going to be developing as a software developer. Before we even dive into the code, then there's something we should talk about called pseudocode. Pseudocode is not a thing in itself. It's pretty much a way to think about programming, which is to say that a lot of times when you're first starting off, the syntax, the semicolons, the parentheses, these things might intimidate you, right? You might be wondering, hey, like where does this comma go? Where does this colon go? How does this dash look? And it's not wrong to get confused on those parts, but also note that the syntax is not the hard part of the problem, right? Figure out where a comma goes. It's actually not that hard once you're absolutely certain that this is what you want to do. In fact, the hardest part of writing any program is making sure that you actually know the logic behind what you're trying to do. And pseudocode is a way to kind of bridge that gap between thinking about the world in a way in which everything kind of just makes sense and there's a lot of ambiguity, to the way that and drawing a bridge from that to a computer function, which is very, very precise and very, very highly logical. Pseudocode is basically a way for us to think about the solution to a problem and describe it in as precise of a way as possible to another human. The other way to that I've heard pseudocode explained pretty clearly is, imagine you have to give a set of commands to a 3-year-old, right? A 3-year-old or a 4-year-old, they're not dumb, but they just don't know. They just don't have as much context about the world as you do, right? So you might say to another adult, "Hey, just Google it." To a 3-year-old, you might say, "Hey, go to my computer, open up this icon, and then Google it." Nowadays, I guess most 3-year-olds might probably already knows how to do that too. But the whole point is just to kind of say that when we think about developing these solutions, it's imperative that we're as clear in thinking as possible, right? So we want to know what the problem is supposed to do and how it's going to be set up. Sorry, so let me just drag these. Okay, cool. All right, so let's say I want a program then that allows me to that's gonna message me if there's a chance it might rain today, right? And so another example would be, let's say I want to create a message that sends an automated email to everybody in my family at a certain time, asking them how their week is, right? These are all programs that I can easily do with a computer. But before I start writing code, I should at least start thinking about how I actually want to build out or implement this. So pseudocode is an informal set of instructions that we write typically in plain English, and it's usually used in the beginning of the development cycle just to make sure that we don't get too hung up on the coding part, and that instead we kind of play more in the realm of clear thinking. So let's say I want to use pseudocode to help a robot make coffee for me. How would I create the instructions for the robot? To a human, I would just say, "Can you make some coffee for me?" Right? To a robot, you can imagine how ambiguous or how hard that task is as a whole, right? A robot probably needs a little bit more granular instructions. And so if we actually do the make coffee program, then the steps will be: one is find the coffee maker in the kitchen, fill it up with water from the sink, pour the water into the from the pot into the coffee maker, find the filter, put the filter in the coffee maker, find the coffee grinds, put the grinds into the full pot into the coffee maker. Measure the coffee grinds, put them in the coffee maker, plus place a pot in the maker, and then click the brew button, and then wait for an X number of periods of time, and after a while, you're going to get coffee. Sorry, I think I went too fast. Okay. The point here is that something as simple as make coffee that we say to a human, that might make sense to us. To a computer, we actually need to break it out into these 10 steps. And in fact, we might actually probably need to make it even more precise, right? Something as simple as measure the coffee grinds. Well, what does that actually mean? Well, we need a robot. If we're writing a robot, we actually need to tell it exactly how much coffee grinds to measure, right? Full pot is kind of an ambiguous term if you're thinking about it from the viewpoint of a 3-year-old even. And so this is an example of just when we talk about writing code, how logical and precise your thinking should be, right? If someone says, "Hey, can you write me a function that does this really complex thing," right? Like email my parents every Wednesday at 8 o'clock. It's not just, "Great, let's write a function that does that." We actually want to break down that process into these individual steps. And trust me, once you have these individual steps, it'll become so much easier, so much faster for you to write the corresponding code for each step. So, and then another example of pseudocode would be, let's say I have 4 rooms in a house and I want this robot to clean all 4 rooms. How will I think about actually having this robot do this? Well, the pseudocode for this robot could be something like: clean the square you're currently on, look at the possible moves you can make. If any of those moves leads towards a dirty square, move towards that area and then go back to where you started from. Right? If there's more than one dirty area, pick one at random. And when you have no more dirty area, that means we're done. So if I start here, this square is now clean. Step 2 says, "Oh, I found dirt in these 2 other squares." So I can just pick one at random. Let's say I go to that one. I go to there. I clean the current square. I check, and now I check my possible moves again. Do I have any dirty squares? Yep, there's one right there that I can go to. So I go to that square. I clean it up. And I check one more time. I find the original dirty square that I didn't go to. I check it. I clean it up. And now, because all the squares that now that all my optional squares going forward are going to be clean, now I've finished my task, right? So what we've done is we've actually written this set of very clear instructions for the robot to run over and over and over again until it reaches the finishing point, which is there are no dirty squares in this path. Right? Sounds very simple. It sounds almost, maybe in the way I'm talking about it, it almost sounds almost like overbearingly so. But trust me, when you start writing real code, planning out what you're going to write beforehand is going to save you so much time than just kind of plunging in and then getting lost halfway through. Okay, so that's kind of, so hopefully that was our hope there, is to kind of help you frame how you think about programming, right? It's problem solving, yes, but it's not just write as much code as possible. It's think through, develop an actual solution, make sure you understand how the solution works, and then break down those components, each of those instructions into code. Then shifting gears a little bit, let's now talk about JavaScript. Which, as we go back to our kind of human body analogy for a web page, whereas HTML is the bones, the CSS is the skin. Now we're moving on to the brain, or the nervous system of the web page, I guess. Okay, so in JavaScript we're going to learn about. So today we're going to learn about the different kinds of data that JavaScript can manipulate. We're going to talk about how to store this data for use for later or somewhere else, and then how to make decisions based on certain conditions. And then lastly, how to organize the code and data into meaningful units. So the history of JavaScript, before we kind of dive into the actual technical aspects of it. Who created JavaScript? It was created for Netscape in the 1990s. So it's been around for 20, 30 years, which is, in the world of computer programming, it's eons, right? ECMAScript is then, ECMAScript can be thought of as kind of like the most standard version of JavaScript. There is an organization called ECMA, and their entire job is to kind of create the rules for what JavaScript is or is not. One of the things that you actually learn if you dive deeper in JavaScript is that JavaScript, like most computer languages, it's not static. As in, the JavaScript that we use today is not the same as the JavaScript that was in place 20 years ago. Every couple of years, the folks at ECMA take a look at the language, they find ways to improve it, they add new features or new tools to make our lives easier. And so even though people may say, I've been writing JavaScript for 20 years, the truth is they've probably worked through several different versions of JavaScript during that time. Why do we teach JavaScript here at Fullstack Academy? Just because it's very popular, right? JavaScript is still one of the most popular languages around, and the reason why is because JavaScript is immensely popular on the front end, as in it can be used to build the parts of the website that you see. So if you think about something like CNN or ESPN or Facebook, right? The web page, so the home page, the news articles, the links, those things are all written in JavaScript because they're the parts that the user sees, and only a few languages allow you to do that. But the other powerful thing about JavaScript is that it can also be used to write the backend. So the parts of Facebook, for example, that you don't see. So those could be, how your friends are connected to one another, how your information is being stored or shared, etc. And so because JavaScript can be used to build both the front end and the back end of a website, we teach it at Fullstack because it just seems to be the most flexible and the most easy way to teach software development, right? You could easily learn, one language for the front end and a different language for the back end, but it feels like it's probably more trouble than it's worth, right? Why not just use JavaScript, which is super flexible, it can be used for everything? That does bring the question up of, well, why are there so many languages? And the reason is because the languages do have different pros and cons, right? It's like asking, well, why are there so many different types of cars if all cars have four wheels and an engine? And the answer is, well, we need different types of cars for personal reasons, for performance, for comfort, etc. Same with programming languages. Different languages have pros and cons, but more or less for the things that we'll be working on in this class, JavaScript more than does the task, and it's also an incredibly flexible language, and we'll be able to definitely accommodate us for anything that we'll need it for. So, like I said, JavaScript is unique as a language in a sense that it can be used across the entire stack. And the entire stack just means the front end, so the parts of the web pages that we see, as well as the back end, the parts of the web pages that we don't see. Client side is what the user sees. Server side is what the I guess it's kind of the backbone or what runs the websites behind the scenes. And then databases are how we store information in databases. And so so everything I'm talking about here, it's kind of more of an FYI. There's nothing here you need to memorize. But another reason, in addition to the flexibility of why we teach JavaScript, is because most websites or software development nowadays is moving towards a single page application that just runs in the browser. So something like, rather than saying, hey, download this separate piece of software to use me, it's just like, hey, let's just run it in Chrome or let's run it in Firefox. Something like YouTube is a great example. And so because JavaScript can be used on the front end and back end, it can also make that a lot easier for us too. And so even something as simple as Gmail or Facebook are being run as single page applications. JavaScript is also great for beginners because you don't need to switch languages, and also because when you just look at the text for it, it seems pretty intuitive. Any questions so far? I know I haven't covered much technical details. It's been very fluffy so far, but just any questions around the context around JavaScript? Everyone good? All right. So today's lesson is going to be very short because, and in some ways, if you've seen JavaScript before, this might seem almost too rudimentary. Whereas if you haven't seen JavaScript before, hopefully we're going to ease you into it. I promise the material is going to get a lot harder, a lot faster over the next couple of classes. Today, the only thing we're going to talk about with regards to JavaScript primarily is going to be data types, i.e., what are the different kinds of information that are used in computer languages. In HTML, we kind of did, there really was no data types, right? We just had a bunch of different elements, which you can think of as that way. With CSS, there definitely wasn't any data types, but with JavaScript, there is data types, right? The way that JavaScript handles a number is very different than the way it handles a string. And so today we're going to talk about the most common data types, what they look like, and then throughout the course of the workshop today, it'll primarily be you guys kind of going through and playing around with these data types, using it and kind of figuring out kind of how they work. So before we get started with the data types itself, let's distinguish two words that unfortunately most developers, including myself, use interchangeably, but they're not the exact same. Okay, so and those words are values and variables. Values are data types that have a specific purpose and an intrinsic behavior. And so what does that mean? If you look on the right hand side, we'll see that there are a bunch of values there, right? There's the number 50, there's the string George, and then there's this false, which is what we call a Boolean value. Okay, a variable then just becomes an identifier or a label for a value. And so if you look at the first example, var, and this word num of states equals 50, var just means we're creating a new variable. Num of states becomes the name of the value for 50. And so now if I ever need to use 50 again, rather than type it out, I could just type in num of states. One immediate thing that comes to mind is, well, why wouldn't I just write 50, right? Because num of states is actually a lot more characters to write than 50. And the answer is because variables are identifiers or labels for values, but variables can change, right? If I do number of states equals 50, and let's say tomorrow Puerto Rico passes legislation to become a U.S. state, well then by tomorrow I need to update my num of states variable now to equal 51. So whereas the value is the value itself, the variable then becomes just a label or a reference for that value. And so in the second example, the variable name is a label for the string George, or for the word George. And then on the third example, the variable answer is a representative or a label or an identifier for the value false. Okay, some rules around naming variables: they cannot contain spaces. They must start with a letter, an underscore, or a dollar sign, and they can only contain numbers, underscores, letters, or dollar signs. Variables are case sensitive. So if I make two variables, one with one called name all lowercase and another variable called name NAME, but the E is capitalized, to JavaScript, those are two distinct variables. And the last but not least, a variable cannot take the place of a reserved word. Reserved words are basically words that are part of the JavaScript programming language. So a great example would be VAR, right? On the right hand side, we see that VAR. Whenever we write VAR in JavaScript, it means we're trying to create a variable. That means we cannot create a variable named VAR because there would be a collision, right? JavaScript will tell you, hey, I'm already using var for something else. You can't use that as a variable name. In most modern code editors, when you type in a reserved word, it will show up as a different color. So it'll either be red or orange or green or something, but you'll get some indication that this is a reserved word in JavaScript, and so you cannot use that as a variable value. And then this is something we won't talk about too much in this class, but it's very important. There are very important implications for this distinction. But for now, just know that we can create variables with either the var or the let keyword. So if I do var name equals George, I've now created a variable called name with the value of George. If I do let name equals George, I've also created a variable called name with the value of George. There are differences between them, but for our purposes, they more or less work the same way. So these are different data types in JavaScript. On the left-hand side, we have what we call our primitive data types. So those are strings, numbers, booleans, undefined, and nulls. And then on the right-hand side, we have what we call the object data types. No need to memorize this now because we're going to go through each one of them individually in just a second. So to start off, we have numbers, right? So numbers are used to perform arithmetic operations. We can do very simple things, right? Addition, subtraction, multiplication, and division. And indeed, when we write out the math, it just looks just like this, right? If I want to do 5 plus 5, I just write 5 plus 5. JavaScript and numbers are able to handle decimals too, or negative numbers. So feel free to use those when you write out your code. Oh, sorry, don't go too fast. Numbers, for the most part, are just very basic. We treat them like we write any other pieces of math. And the only other thing to know with numbers that's a bit tricky is just that, usually speaking, for this class, let's use numbers with other numbers, right? So let's not add a number to a string. I can tell you what it does, but you will cover more of that in the full-time curriculum. Okay, so numbers is a data type in JavaScript. If I write an arithmetic number, I can do mathematical operations with it. The other data type then is a string. So here, a string is just a series of characters, and we designate the beginning or the end of a string with either a single quote or a double quote. With strings, I have the ability to strings, I have the ability to add strings together with the plus sign. So that looks a little bit like math, but it's actually not. It's a process called concatenation, which basically means if I have two strings, I can just shove one onto the end of the other. And so on line 3 here, if I add full stack to academy, then I've basically created one longer string called full stack academy. And all the strings have a length property. So if I call the variable, so on line 1 here, I created a variable called full stack, and the value of that full stack variable is the string full stack with a capital F, and there you see it is in blue. If I do that variable, so full stack.length, I get back 9, which just tells me how many characters are in the string, and if the string is empty, then we'll return 0. And so therefore, if I know a variable has a string value, and I do that variable.length, I am guaranteed to always get back a number. Everything good so far? Yes? Good? All right, so keep it moving then. Sorry. This seems kind of silly, right? But booleans are also data types in JavaScript. And a boolean is basically a binary data type with two possible values, true or false. And so, like I said before, computers do very poorly in ambiguity, right? Everything is either do or don't do. Booleans, in that case, it comes in very, very handy for helping a computer understand what to do and what not to do in the most explicit way possible, right? There's nothing more explicit than just having a data type that has two possible values, either a go or a no-go. We also have friends. We also have our friends nulls and undefined. Don't worry too much about these for now. Just know that they exist, and the main difference between the two is that an undefined data type essentially means that a variable has not been given a value yet, whereas null means, oh, I've given this variable a value, and that value is there is no value. a little bit meta. Once again, don't concern yourself too much with this for now, but just know that they exist. And then we can move. So everything I've talked about so far, the numbers, the strings, the booleans, the nulls, and undefineds, those are the primitive data types. Don't worry too much about what they mean for now. Just know that the primitive data types tend to be the simpler data types. And then here we move into the more complex data types, which we call objects. And so the first one we'll take a look at is something called arrays. Array is designated by the opening bracket and the closing bracket, as you see in the image there. And basically, an array is a collection or a list of values. In fact, in other languages like Python, arrays are actually called lists. In any case, an array is just a list. We start the list with the opening bracket, and we close the list with the close bracket, and then everything in the list we separate with a comma. Arrays can hold as many different values as possible, and so we can hold, in this case, in the example here, we see as holding booleans, we see as holding strings, and we see as holding a true, a string, a false, and then a number. And that's all fair game. An array is basically this container that we can use to hold as many things as possible. And then each value is separated by a comma. This is the contrast with something called an object. And we'll talk about objects in way more length next Tuesday. The objects, you can almost think of it as a dictionary, in that it's a collection of properties and their values, or what we call key value pairs. In the same way that a dictionary is a collection of words and their definitions, objects are collections of properties and values. Yeah. And so you can think of an object like a group of keys. Once you have the key, you'll be able to access its associated value. Like I said, don't get too concerned about this for now. We'll talk more about this next Tuesday. And then last but not least, we have our old friend, the function. A function is essentially a fancy way of writing a reusable chunk of code. It's like a recipe, in that we can use it over and over and over again. Typically speaking, in software development, if you find yourself writing instructions for how to do the same thing over and over again, or at least more than twice, then it probably makes sense to take that piece of code, put it in a function, and then just use that function going forward. It'll make your life a lot easier. So here we see this function on the right-hand side is called bake cookies. The function takes in 2 arguments. It does a bunch of things to them, and then it also calls additional functions as well. We'll also talk about functions in more depth next Tuesday, so don't get too stuck on this for now. There might be a little bit of this in your reading, but for now you can just think of functions as 1, reusable pieces of code, and then 2, they're reusable pieces of code that you can execute, where you can run, where you can do things with. Yeah, so this is just breaking down the function a little bit more. Okay, and then last but not least, then it's not really a data type, it's something in JavaScript that you should be aware of, our old friend, the comments. There's multiple ways to write comments. You can either do a single line comments, in which case you just start it off by doing 2 backslashes, and it goes until the end of the line. Or you can do multi-line comments, which start with the backslash asterisk, followed by the asterisk backslash, which is very similar to what we see in CSS as well. And so comments are just another ways for you to leave notes to other human programmers who are reading your code. And that's pretty much it, right? So it's not a ton of direct material. Like I said, today all we're doing is trying to get everyone on the same level in terms of saying if you've seen JavaScript before, here is just kind of a quick refresher on the different data types that exist. On the other hand, if you've never seen JavaScript before, here's hopefully a not as intimidating introduction to basic data types in JavaScript. And then next Monday and Tuesday, we're going to go through and start building kind of more complex functions or instructions with these values. Are there any questions?